So welcome to Finite Element Methods. I have invited a distinguished guest. His name is Angel Lopez. Just a little bit more about him before I transition over. And I want to make sure that you guys basically get a sense of who Angel is before I introduce his bio, and we can go through a question and answer session here with him.
My name is Angel Lopez. I've been with Pacific Scientific 13 years. I'm the new product development engineering manager. My role basically encompasses making sure that customer requirements basically become products. So I'm responsible for, along with my engineers, to make products a reality.
So he has more years of experience in the video because that video is older, but he's director of engineering, has a lot of experience. You know, one of the things I'm trying to do in this course is to bring experts across the field that are experts in different areas, right? I brought design engineers, I brought analysts, I brought managers, I brought VPs to give a more top level view. But one of the things I like about Angel is that he's product driven. That's his end goal is to get a new product out the door, right? And not a lot of people have that skill. So for that reason, I have invited you, Angel. Thank you for coming in. You can see the bio here. He's with Pacific Scientific, and the education is provided here at the bottom. Loyola Marymount, master's degree and a bachelor's degree from University del Turabo in Puerto Rico. So Angel, welcome.
Thank you for having me.
No
Hello,
problem.
everyone.
I'm very glad you joined us. I want to kind of start off first asking you this question, you know, for an engineer to be able to succeed in being able to deliver a product in time that goes from concept to out the door, what kind of strengths an engineer needs in the context of the person, but also how that person interacts with the team?
Okay. I think first things first, obviously a strong foundation from the technical aspects is important. But beyond that, it's a resiliency of look beyond failures. When you're developing products, the first thing you need to be accepting of and take it as a part of daily life is that you're going to encounter a lot of failures. Some people can't deal with that, and they restrain or they move into other things because they do not accept that failure is part of product development. And that's where resiliency really comes from, because you will encounter a lot of it, but then you need to focus on what are the lessons learned and the opportunities that you will be learning in order to make the mistakes into solutions and in order to deliver a final product in the end. And then from a team's perspective, no man is an island, is what they tend to say. And that is not more real than as a product development or in engineering, applications engineering. When you're trying to go from concepts or ideas into developing a product, no engineer will be able to go from cradle to grave and do it by himself. You need a team, and the team goes across the spectrum of not only designing, but also manufacturing. We can come up with ideas and concepts, but we don't make them a reality by ourselves. We need technicians, we need machinists, we need manufacturing engineers, we need quality engineers, we need test engineers. And as a team, we are able to realize these things and becoming reality at the end of the day and delivering.
That's awesome, Angel. So that's the positive things that the engineer has to have. But you have been manager and you're director now. Mm-hmm. What you do not want to see an engineer be that will prevent from a product getting out? Like what kind of engineer you do not want to have? And I say it a little bit strong. It sounds very strong, but I'm just being candid. You know, there's certain types of engineers that usually don't want them in your team because they're not going to take you there. So can you tell me what characteristics you don't want to see?
So the first and foremost is the individual that works in silos. They tend to work by themselves. They tend to be like the Lone Ranger. They don't interact proficiently uh, amicably with other team members. That is an honor to begin with because, like I said, I mean, in order to drive a product to completion, you need a team. So if you're used to just doing everything by yourself, you will never be able to deliver uh, the right product and on time, of course, and on the budget and all that kind of stuff. The other thing is individuals that tend to um, bring all the problems, right? This doesn't work, that doesn't work, but they don't bring solutions or ideas to the table. It's always about what the problem is, but never how can we solve the problem. Here's what I've looked into, and these are, let's say, the top 3 ideas that I have or concepts that I have. And then bring in, I have 3 things, I don't know which one to go first or prioritize. Can I get help there? And that's a different perspective than just bringing problems with no solutions. So I will say those are the 2 top in my list.
So they're not they're bringing rocks to you, but they're not telling you how to overcome it.
Correct.
Got
Upfront.
you. Got you.
Upfront. Yep.
Could you tell me a little bit more about the value that you see? And you can be blatantly honest. When you see the value of modeling simulation in the acceleration of a product delivery versus when you see it valuable and when you don't see it valuable. So basically, give me a balanced perspective.
Okay. So everything is driven by schedule, right? So the faster is better. And typically that's the mantra that you will hear on a daily basis. That is true. And in product development, what we tend to do in order to reduce schedule is look at what has been done before and how can we leverage for the most part. That's not always, a slam dunk of finding a solution. And when you're dealing with something that is truly conceptually to begin with, there's no data, there's nothing that you can leverage or rely on. That's where simulation comes uh, uh, to meet the need. Because now I might not have an end of it all answer, but I can get close enough by estimating. And then having said that, I mean, that accelerates significantly development of product. Now, what we need to keep in mind is that, okay, if I have some information to leverage on, I can kind of take a speedy and proposition or path to a solution by leveraging simulation. If I don't, what do I leverage against? Because the estimation from a design or a final element, I know needs to be validated. So it's a trade-off of engineering judgment between what can I leverage with existing data and what do I need to validate in the end. And in between, in order to bridge that gap, do I need to look at a little bit of over designing and where can I take those actions? Because you can over design everything or most of the time it won't work. But keeping in mind that in the future, near future, I need to validate it. So upfront, aside from the results of my concept and my analysis, I need to start thinking, how am I gonna do prototyping perhaps? What kind of a testing I'm gonna use to validate the design? And always circumvent back, like in a closed loop format. I put a concept, I do the analysis, I get a result, I go validate with data, with testing, get my data, come back to my analysis. How close was I? As you move forward, you might get that product out the door, but now you have lessons learned and you have validated data for the next time around. Now I can leverage on that because I have a working design that is validated.
That's awesome. That's a really good balance. May I summarize to see if I got it right? I think what you're saying is that to accelerate product development, you can use heritage information, and you will have some delta changes to those designs. And you could test, but modeling can help you, increase your chance, perhaps,
Mm-hmm.
if you have those delta changes, right?
Absolutely.
Okay. Have you seen situations where finite elements or hydro codes, which is what I think you guys use, have you seen the benefits of those kinds of tools in the design process?
Yep, absolutely. We look at it from different perspectives. It really starts always by what are the requirements and what concept or design ideas will drive the product into that final solution, meeting all the requirements. You can look at it from 2 perspectives. when you're looking in the linear range of material properties, you always have the standard finite element and whatnot. What we do is a little bit different, in which we are primarily and foremost an explosive manufacturer. So we work with pyrotechnics and propellants and high explosives. So that said, the type of simulation or analysis software that we use is called a hydrocode. And because we're dealing with things in the millisecond range and highly energetic, highly dynamic, and in that area, we typically look at hydrocode for that, the initial dynamic input, and then we take those results and move them for the most part for the finite element analysis software in order to look at structural responses and so forth and so on. So we have a safe product that works all the time. Now, if I look at trying to use the same approach on a finite element, that won't work, because in the realm of pyrotechnics and explosives, everything is so fast that you're looking at highly nonlinear strength materials don't apply, and so forth and so on. So it's really highly specialized software in that end. But we look at it from both perspectives and combine it to leverage the gap into a final solution.
Thank you, Angel. That's amazing. Are errors common in analyses, and are they forgiven? I mean, I personally had in my career have made a lot of errors in my models, but in this area of expertise, errors are quite common. Given that you're product driven manager, things like that, what is your take on engineers that that make mistakes?
As part of our daily lives. I've made many mistakes myself throughout my career. I think that you need to look at mistakes not as an end of it all, but as an opportunity to learn. That's I tend to tell my guys, failure investigations are not ideal, but they're definitely a fantastic learning resource. When you have a failure and you need to dive deep into what's the cause of it, that's when you really put your investigation hat and you focus on the details and try to remove the fluff. I look at it as an onion. I need to start peeling off the layers until I find the real root cause that is typically more complex than we would like, but that's really what drives the learning and the makeup and the development of an engineer. So it is how I tend to define it, as an expensive education beyond just our formal university education, but it's a fact of life in any industry developing new products.
That's a very interesting perspective. So I read how you couch it, where you're stating how mistakes are a learning experience, right?
Yep.
And that's an awesome viewpoint there. Another question I have is, how do you know how to hone in a product that will satisfy the customer? How you keep the customer satisfied that the product that you're delivering is the right one for what they're looking for? And when they're not satisfied, how do you deal with your team in trying to revector to try to use design and engineering analysis to get you back on track, maybe testing even?
Okay. So typically we tend to look at the requirements up front and have a lot of communication discussions and meetings up front in order to make sure that off the bat we have an understanding of where are we driving towards the end result. As part of any development process, you will have, let's say, phases or toll gates. And we split things into the conceptual phase and then into the prototyping phase. And then we move into the validation, design validation and testing phase. And this is early on, prior we go and produce anything for, let's say, a qualification, or let alone delivering hardware to be used in flight, for example. Throughout that gated process, we are continuously communicating. If we encounter any issues, then we immediately communicate and provide both ways feedback. Here's the issue that we're encountering, here's the path that we're taking, and then we present the rationale, typically with supportive data. We get feedback from the customer, and we continuously move between phases on this closed loop, so to speak, to make sure that we're both on the same agreement, that we understand what the issue is or what the result is. And when we actually finally resolve the problem, we agree on the results of the data before we move forward. Along the same line, sometimes they present to us a long list of testing that they will require. And then we can guide and counsel into, that entire list is not necessary. We can reduce it by X or Y, and here's the reasoning, or here's a similar product. We have this experience and we have data to back it up. And that allows to somewhat tailor the testing process, bring it to a shorter cycle. And obviously time is money. So if you can bring testing to a smaller cycle, you're saving dollars on the program. And that's something that everybody will, in the end, will be happy about. You get faster product and at a reduced cost.
That's amazing, Angel. We have a lot of in the audience. We have a lot of students are looking at what's next for them. And I look at your career, and it looks very productive. I didn't put all your steps from education to where you are today, but can you tell me what are the biggest lessons that you've had in your career in terms of growth in knowledge, growth in terms of what it takes to be a good engineer, growth in terms of what it takes to be a good leader? It's pretty amazing, your career growth. And so I just want to get a feel for what were the key ingredients, and what was Angel like during the education stage, and what is Angel like today? And that delta, what caused the delta?
So if we go back to my college days, that is where it all starts. Coming into engineering, it was basically mainly out of curiosity. I was always interested in how things work. But what really kicked off the development of who I am today, aside from curiosity, was actually engaging in productive endeavors. And that being said, during my college time, I was every summer, I was on an summer internship, because I realized very early that what I lack in experience as a student, I could kind of bridge the gap, not 100%, but a little bit, by acquiring some experience doing summer internships. So through my entire bachelor's degree, I did summer internships, and that is actually what opened the door to my first job. Right off the bat after graduation, I got the first job. And along with that first initial experience was a negotiation to get my graduate degree basically covered for. So that's how I ended up getting my master's degree, all paid for by the company in exchange of time, right? So working to kind of pay back the education, and that worked beautifully for at both ends. It was a win-win situation. And then the other thing that I will add to that, not only during my internship days, but also throughout my career, is always look for mentors. Look for people that either you admire for how they develop their career, or you admire because they have something. Let's say I would like to be that person one day. I would like to be, whether it is the way that they present in knowledge, the way that they present just in relationships. It's not all technical know-how. Engineering, like any other thing, is based on relationships. And if you get the right relationships, you can get the right path along the way in different areas of life. So mentors are critical. The people that you hang out with, what are the discussions that you tend to have? Because those are the individuals you spend most time. Those are the individuals that you will be learning the most from. So professional relationships and so forth help quite a bit. And then aside from that, is always looking for increasing responsibilities. We can all get the foot on the door on a company, get a job, and then do the same thing every day. You can be there for your entire career, or you can look at every opportunity or every day to learn something new. And then along those lines, increasing responsibilities will get you to the next step or that next promotion, so to speak. You combine those factors, and pretty much you can guarantee success in your life.
That's amazing, Angel. I know that every time I've contacted you, you'll tell me that you're learning something new in finance or stock or something. You're always learning. That's something that I admire about you. If now you were to reflect back in your career, what are the areas that you felt that you could have done better? And maybe you don't want to share those, but But if you can maybe at least share one. For me, communication was a problem initially for me. I had to really work on that,
Mhm.
and I improved it. What about you?
So for me in the beginning, like any newly graduated individual, especially within the engineering sciences, you get the degree, you think you know everything. So in the beginning, I will say as well, communication, building those relationships, because I thought I knew everything. As you grow older, you start understanding primarily that you will never know everything. You will always have something new to learn, especially if you're an engineer, and you can definitely always learn something new from a coworker or a friend or whatnot. That everybody, regardless of where they stand in life or their position or titles, have something to teach us. So as long as we go out in the world with that mindset and open mind, you will always have something new to learn from everybody that you encounter in life. So those two things, making sure that set ego aside, we don't know everything. There's always an opportunity to learn, and there's always an opportunity to learn from everybody. I think those are the key aspects there of growth, personally and professionally.
That's amazing, Angel. Another question I have written here is, we have an audience that's very diverse. I have students from the medical industry, mathematicians, engineers, civil engineers, mechanical and aerospace, and also I have students that are from physics. And that diversity pushes me to ask this question, because the other type of diversity I have is I have bachelor's degree students, master's, and PhD. And a lot of times, you reach a point in your career or your schooling where you're trying to figure out what is next for you. If you're a bachelor's degree, you're wondering, should I pursue a master's? And if you're a master's, you ask yourself, should I pursue a PhD or should I go straight to industry now? Same for bachelor's. And if you get a PhD, you're wondering, should I become a professor? Should I go to postdoc or should I go to industry? That decision making process is not easy. So I don't want you to give a one answer fits all, but can you tell us some of the key ingredients that it takes, what factors they should consider in the decision making process as they think through it, noting that errors in decision making are okay, that's normal, and you can always go back to school.
Mm-hmm.
But anyway, can you give some thoughts there? And I acknowledge that there's no perfect answer here.
Right, right. There's definitely not a perfect answer. I think the most important thing is making sure from day one that you understand yourself. What are your likes and dislikes? Um, Before or along the path of in parallel with trying to make these decisions of what's next for you, career-wise or decision-wise. Me personally, I'm a practical individual. I'm an applied kind of individual, always been. So for me, in making decisions towards my career was always about, yes, I learned something from a book or research or an investigation, but how can I apply that knowledge? And there was always that struggle. Still to this day, it's nothing that it was a past. It's still to this day, there's always this struggle of when I'm learning something new or new area or whatnot, how much of the science and the theory I want to dive into before I start shifting into, okay, how can I apply this? What is the practical aspect of things? But that's only me, because that's I understand now that that's who I am. So I think that will be really important. It's understanding the individual first in order to know or at least to support that next decision. Um, at the undergraduate level, when you come out of an undergrad, there's always the need of, okay, is my next step graduate school or my next step is professional experience, right? Um, I can say for a fact nowadays that we live in a competitive world, and the world is not only competitive, where it's also now global. So there's global opportunities, local, regional opportunities, but competitive nonetheless. A graduate degree nowadays, it's kind of expected at this day and time, at least within the engineering sciences. Then moving forward from there, in order to go after a PhD, again, the first thing is understanding the individual. And the next one is what area with the professional aspects do you expect to go, or you will be more at home, so to speak, right? Because that will be a key aspect answer as to moving to the next level as a doctorate versus staying, let's say, with a master's degree. And there's always the opportunity that you want to get some professional experience and then you come back to school. And me personally, I actually think about that sometimes. So, at this point, maybe I can go back and get a PhD, right? But it's a personal decision after many years in the industry.
That's pretty amazing, Angel. Really, thanks for that insight. Really helpful here. I do want to open it up now to the audience here. You made the time, Angel, to support this. I want to ask, do you guys have any questions for Angel that you want to tackle? I have other ones, but I want to give you a chance to go first. Who wants to go?
I see that
Hello.
you state. Oops.
Go ahead, Steven. You
You can
first.
go first.
Yeah, you first.
Okay. I saw that you stayed at Pact Scientific for a really long time, for 17 years. Do you think, like, I know nowadays, like, a lot of people are recommending switching between jobs like every 2 years just for like career purposes. Do you see maybe like some advantages towards staying in a position for longer that you might not have seen, or like what was your decision process in that?
Decision process for me to stay this long, and for the record, Pacific Scientific is not my only experience professionally. I started in the Aerospace Corporation in LA. That was when I went to graduate school. That's who I was employed by full time. The reason for me to stay within Pacific Scientific is because after my internship was in the ordnance world, back in my undergraduate days at Los Alamos National Laboratory. That experience put my foot on the door at the Aerospace Corporation with the Ordnance Office under the Engineering Division. And that was, and still is to this day, is an area of science and engineering that is started back in the day as a black box. And nowadays, this is 20 some years after I graduated as an undergrad, is less than a black box, but there's still a lot of opportunity to develop it into a full science, applied science. So there's always something new to learn on a daily basis. When you combine that with the opportunity to be at a original manufacturer that is essentially on a daily basis at the very edge of what is next to come, you will never be bored. And to me, that is a critical aspects of my daily life. It's not just a job to get a paycheck, but am I bored doing what I'm doing? Or am I excited to come to work and excited to learn something new and excited to, do what we do on a daily basis? And that is the key aspect of why I have stayed so long. Because here, there's an opportunity for me to learn something every single day. And because we are an original manufacturer, we bring ideas into results and concepts into products on a daily basis. So you see the entire process, and it's across the spectrum of technologies. That to me is just the highlight, so to speak, of my days. Now, the opportunity of staying or behind the long career with the same company has also brought the opportunity to continue increasing responsibility and be where I've been able to get as a director of engineering today. But that was never intended to begin with. It was basically a byproduct of my interest in the engineering as a fundamental, as a foundation to what we do.
Yeah,
Now,
I really appreciate those comments. And I also want to really emphasize that when you hear somebody saying that you should have to switch a job every year, or every 3 years, or every 5 years, or you have to stay in a career your whole life, you want to be careful with those people giving those advices, because a good advice, first of all, is not generic. Number one. Number two is balanced, like the way Angel explained it when I asked him the question about which way you should go. And everybody's career path is different. Not every career path has to look the same. I've had former students that dropped from bachelor's degree and started their own company. Okay. And they're very successful. I'm not suggesting that you guys drop, school, But I'm saying that there's a lot of models to success and there's no one size fit all. So if you ever hear anybody saying you have to do it this way to be successful, I will really research it more.
Right.
Even when Angel, I want you to notice that even when Angel stated, you know, master's degree, it's kind of expected. He didn't tell you that you have to do it, but he's saying what the expectations are in the industry. He did not say you better do it, right? So let's just be careful
Correct.
there when you hear things like that. Angel, any comments on what I just stated?
No, you're absolutely right. Absolutely right. The other thing I wanted to mention is, yeah, there's people that changes job or recommend doing this every so often. But keep in mind what I said earlier, it's really a decision based on at the individual basis. You need to really understand yourself, and then you need to ask yourself, what are you looking? What are you after? My definition of what I am after on a daily basis comes to 2 points, and it is, in my current job or my current existence professionally, am I learning or am I earning? And the ideal condition is what I'm doing both. If you're only doing one, then it's just a matter of time before you decide to move on. When you have both conditions met, it's very unlikely that you will decide to continue moving forward to another opportunity because you got the two most important aspects of the opportunity right in your hands. You're earning and you're learning.
Excellent.
And if you're value added to the corporation that you're working for, when you're earning and learning, the next logical step is you will grow in your career. No
Excellent.
company will keep you at the same location if you're continuously learning and continuously building your value to the company. And
And
only you
another
can
thing
define that.
Another thing I want to point out, Angel, I want to see what your perspective is. I know engineers that have been a Valve engineer for 45 years. I know engineers that have stayed a design engineer using SolidWorks the rest of their lives. And I don't feel very eager to criticize them for doing that
Mhm.
because sometimes you found your passion. Maybe that's
Correct.
all you want to do the rest of your life, and you're so excited to do it, and that's why you're doing it forever. And I know people in the 80s that keep doing what they want to do and they never sought a promotion to be a manager, engineer, or director because they felt that they found their passion and that's what they wanted to do. That's how they wanted to die. Angel, do you have a comment on
Correct.
that? Because I've seen that quite a bit.
I've seen that too. I've experienced other coworkers and friends, and they're under the same situation, and you can offer them what somebody else might define as a better opportunity, and they're extremely happy doing what they're doing for the rest of their career. But the counter to that is not only they're happy, they're the best at what they do, and that's a key differentiator.
That's very excellent. There is that perhaps you're mediocre and you stay in that for the rest of your career. Perhaps that person could try their best to keep growing in whatever they're doing if that's what they choose to do. Yeah, that makes perfect
Correct.
sense. Yeah, who's next? I think it was Lee.
Sure, mentioned it with your last question about like how your connection in from like Los Alamos led to the Aerospace Corporation and then to Pacific Scientific. So I was just wondering
Mhm.
if you have any advice on like building up industry connections to like sort of to try to like get those opportunities or like learn about like different fields that you might be interested in. Like when you graduate from college, you don't really know everything about the industry and like even like what opportunities there could be.
Correct. So for me, it started with internships, and that kind of opened up those connections and that networking uh, for per se. Another big one when I started working back in the aerospace corporation, it was getting couple of angles. One was the conferences. We used to travel every year to write research papers or give talks and conferences. I remember one of the ones that we used to go every year was the AIAA Joint Propulsion Conference. And it was critical that you participate in experiences like that because that accelerates your networking opportunities. Another one was we will have opportunities for continuous education. So as an example of that, we had, I think it was called the Aerospace University. So they will give free classes with other experts within the company, And that was another opportunity. You take the class, you learn something new, and you network with people that most likely than not will help you in the future to solve problems or to hone in coaching or mentoring, and therefore accelerating, whether it's the knowledge base or career-wise. And other than that, I mean, it's looking at local events, local associations, in order to open networking opportunities. Because really the breadth and depth of a career from a relationship and people standpoint comes from your network. And that not necessarily you only find that at your place of employment. Does that answer your question?
Thank you for that insight. That answered my question.
Okay.
Eduardo, you're next.
Yes. Hi. Thank you for coming and speaking to us. And also, you already touched on it a little. Like you've touched on the qualities that you don't generally want to see in an engineer like at the beginning of the talk, but I wanted to know if you could like pinpoint 3 qualities, let's say like 3 technical qualities that from your experience are very valuable in an engineer, and then 3 non-technical qualities, so maybe like social.
Okay. So on the technical aspects of things, at least on our day-to-day basis that we apply almost on everything that we touch, engineering fundamentals. You will be surprised how people look forward to high education, but where there really needs to be the fundamental understanding and know-how is in the basics of engineering. And I'm talking really basics: heat transfer, fluid mechanics, thermodynamics is a huge topic for us, particularly the physics, because with those fundamentals is what primarily everything that we do functions. And then after that, we go into the higher level, engineering or mathematics and whatnot. When you're looking at the higher level, at least in our case, it will be because we're applying resources like software and such, that you will need that higher level education in order to understand the in and outs, the inner workings of the software. Because if you don't understand that, then there is no point in using a software. You will put inputs and you will get results. You don't understand how it works. You don't understand the algorithms, as they say in the industry, garbage in, garbage out. So most of the time, the fundamental education that we will get in as an undergrad is not necessarily enough to understand the higher level understanding of mathematics and physics and whatnot. So I will say the fundamentals, you have to have solid fundamentals to be able to successfully build upon that in your career. As far as the non-technical aspects, like I mentioned before, your ability to work with other people. And in a diverse world that we live today, it doesn't matter the background, ethnicity, where they were born, where they come from in the world. We have to be able to work with everybody as a team, because we all have an expertise that we bring to the table. And there might be.
I can just do one. I can just hit a few.
There,
and you let me know.
There might be opportunities or times that you might not even get along with an individual in your own team. But guess what? We have to learn to get past those, because we have a job and a responsibility to deliver. And we have to find a way actually to work together and work with each other. So to me, that will be the basic aspects of the non-technical, is the ability to work with everybody in order to drive to the end result.
Thank you very much. That answers my question. And the answer about the technical skills is very interesting, because it really matches what the professor said and what the purpose of this class that we took this quarter was, which is like understanding what goes on behind the software.
Mm-hmm.
And the importance of hand calculations, and importance to do sanity checks. Like I said before, we've seen horrors where there's unit errors that can cause magnitude error in the results. If no Hancock was done, it would not have been caught, right? So a lot of the software don't tell you what units you're using. You're keeping units being tracked, basically in a notepad or in your head pretty much. So let me see if there's other questions here that you guys may have.
If I may expand on what you just said about the hand calculations, that is actually a very, very important topic. Like I just mentioned, garbage in, garbage out, when we're using software, we don't understand what it does or behind the scenes, right? The key critical requirement that I ask from my engineers is to always have at least a basic understanding of the hand calcs to have an idea of what the result of the computer simulation should be. And when that result, because it will most likely never be a perfect result, when can you call it a day? It's close enough with the percentage of error that we can live with before we move forward. But if I see an engineering analysis or a simulation analysis without hand calculations, I don't want to see that report. I don't read the results. They don't mean anything if you cannot support it. You have to do your checks and balances when you're doing simulation, FEA, hydrocode, whatever it is in the software world, in order for you to be able to stand on solid ground to present your results, because you know that they're correct.
That's excellent, Angel. And the opposite actually has happened to me, where my Hancock was actually wrong. So, for example, take a cylinder under pressure. The hoop stress is supposed to be PR over T, the pressure times radius divided by thickness. And the axial stress due to pressure is pressure times radius divided by twice the thickness. So sometimes I have the tendency of swapping things around. And I remember simulating a problem with bending and pressure and all that. And I was wondering why is everything in the software swapped by two? And I realized it was my own Hancock that was swapped. so sometimes the simulation can also remind you that your Hancock is wrong too. So it can go the other way.
We're all humans. We're not
are
robots.
humans.
Gotta keep that in mind. Yep.
That's correct. Any other questions you may have? Well, thank you very much, Angel Lopez. I really appreciate you coming and talking to us, to our class.